Today's lesson has to do with the concept of the frame of reference. As you shall see, the frame of reference has to do with your perspective as you're looking at things moving. Things may be different than they seem depending on your frame of reference. For our first example of frame of reference, imagine you're going to the airport to board an airplane. If you've been to the airport, you've probably seen they have these long moving sidewalks to help you get along where you're going faster to the airplane. So imagine yourself standing on one of these moving sidewalks. And you get on this sidewalk and you're just standing there. You're not actively walking, you're just standing on it. But it's moving along at 2 meters per second. So even though you're not actively walking, you're not moving, it's moving you at 2 meters per second. Now let's say there's somebody looking at you. They're standing just on the ground away from the sidewalk there. And they look at you and they see your head above the rail there, and it looks like you're moving at 2 meters per second. So from their frame of reference, you look like you're moving 2 meters per second. From your frame of reference, you say, I'm just standing here. So again, as they see you moving 2 meters per second. From your standpoint, you're just standing there. Now suppose about halfway down that moving sidewalk you realize, oh my, I'm late for my flight. I better start getting a moving here. So as you're on your moving sidewalk, you decide, I better start walking here. So you start walking on the moving sidewalk at 3 meters per second. So from your frame of reference, you have just started walking at 3 meters per second when you weren't moving at all before. However, the sidewalk is still moving at 2 meters per second. Now from this individual that's observing you, all of a sudden, as they're looking at you, well, you were moving at 2 meters per second, but now you're moving 3 meters per second faster. So we add the speed of the moving sidewalk and the speed of you walking, and from their standpoint, they see you moving at 5 meters per second. So from your frame of reference, you're walking 3 meters per second, but from their frame of reference, it looks to them like you're moving at 5 meters per second. So we have one frame of reference, the person who's outside of the moving sidewalk, just standing on the ground, seeing you moving, and then we have your frame of reference. So they see you moving 5 meters per second from their frame of reference, and you just feel like you're walking at 3 meters per second. Two different frames of reference. Now for our next example, imagine a train. And you're riding this train, and you decide to take a little walk up the aisle of the train, and so you're walking along at 2 meters per second. However, the train is rolling along at 30 meters per second. Now you're inside the train, you don't really notice the motion of the train. To you, you're just walking 2 meters per second through the train car. However, if somebody happened to be standing on the ground outside the train and watched the train go by, and they saw you through the window of the train walking 2 meters per second towards the front of the train as it's moving 30 meters per second, what do you think from their frame of reference it would look like you are moving, the speed that you're moving from their frame of reference? Well, you would take the 30 meters per second the train's moving and add the 2 meters per second you're walking, and from their frame of reference, it would look like you're moving at 32 meters per second. So once again, we have two different frames of reference. You inside the train, as far as you can tell, you're just walking at 2 meters per second because you don't feel the motion of the train moving along. But from the person outside the train who sees this train moving and they see your head through those windows, they see you moving at 32 meters per second. You take the speed of the train, add the speed that you're walking, and from their frame of reference, that's actually how fast it appears that you're walking. More accurately, I should say, not that you're walking. You're walking 2 meters per second, but it looks to them like you're moving at 32 meters per second because they see your walking speed added to the speed of the train. So again, two different frames of reference. Okay, now let's consider another situation dealing with frames of reference. You've decided to go on a cruise, and you're on a ship out in the ocean cruising along, and one morning it's so nice outside, you decide to go take a walk. So you start at the middle of the ship, and you start walking towards the back end of the ship. Let's say you're walking about 3 meters per second towards the back end of the ship. Well, the ship is actually moving forward at 15 meters per second. From your frame of reference, you just feel like you're walking along at 3 meters per second towards the rear of the ship. You don't even notice the motion of the ship because you're on the ship. It's moving along, but from your point of view, everything around you, everything you can see, the chairs on the ship, the smokestack on the ship, the other people on the ship, they're all moving with you. So in reference to them, you just feel and look like you're walking backwards at 3 meters per second. Well, now let's say your large cruise ship is passing some guy in a little boat out there, and he's not moving. He's just sitting in the water enjoying the nice morning air. Maybe he's fishing, and as a cruise ship goes by, he notices you walking on the back end of the ship. Well, now from his frame of reference, he sees the ship moving along at 15 meters per second, but then he sees you walking towards the back at 3 meters per second. So from his frame of reference, we'll take the 15 meters per second the ship's moving, and we'll subtract the 3 meters per second that you're moving because you're walking in the opposite direction of the ship. So to him, it looks like you're actually just going how fast? How fast would you think, hit from his frame of reference, it would look like you're walking? That's right, 12 meters per second. We'll subtract the 3 from the 15. So once again, we have two different frames of reference. One frame of reference is being on the ship, where everything on the ship is moving. The other frame of reference is being out in the little boat in the ocean that's not moving at all as the ship goes by. And so, again, we have two frames of reference, on the ship and away from the ship. On the ship, it looks like you're walking 3 meters per second. Away from the ship, it looks like you're moving in the opposite direction at 12 meters per second. Now let's consider one more example of frame of reference. You're going to a football game. Here we see the ticket booth. Somebody's inside the ticket booth selling tickets. And we'll have somebody walk up to the ticket booth here, buying their ticket. They get their ticket. We'll call this person Taylor. We'll say this is Taylor. Taylor gets their ticket, turns around, and starts walking away at about 2 meters per second. As Taylor turns around, she notices Joe. Yeah, there's Joe back there. Joe's late. He got to see the kickoff, and he's late for the game, and he's running along at 5 meters per second to get his ticket so he can get in and see the kickoff to the game. Well, Taylor's moving towards Joe now. They just about run into each other. Joe's moving so fast. Taylor's moving 2 meters per second. Joe's moving 5 meters per second. So as they approach each other, to Joe and Taylor, it looks like they're moving towards each other at 7 meters per second. From their frame of reference, as Joe's moving towards Taylor and Taylor's moving towards Joe, we would add their speeds up. Joe's going 5, Taylor's going 2, and they're approaching each other at 7 meters per second. So from their frame of reference, they're moving towards each other at 7 meters per second. Now let's say Floyd's out there, and he's just watching all this happen, kind of having a little chuckle as they about run into each other. But from Floyd's frame of reference, he sees Taylor moving 2 meters per second, and he sees Joe moving at 5 meters per second. He has no perspective that they're actually moving towards each other at 7. He just sees them individually moving, one at 2 and one at 5. So, again, we have different frames of reference here. Taylor and Joe looking at each other. Looks to them like they're approaching each other at 7 meters per second. Then we have Floyd, who's not moving at all, and all he sees is Taylor walking at 2 meters per second and Joe running at 5 meters per second. Again, it's all about frame of reference. So as we consider problems dealing with frame of reference, what you want to do is look at the different motions involved. And where is your frame of reference? Are you outside the whole situation? Or are you inside, for instance, on the train, on the boat, on the moving conveyor belt at the airport? What's your frame of reference? Do you need to add speeds together if they're moving in the same direction? Do you need to subtract the speeds if they're moving in the opposite direction? It all depends on your frame of reference.